Okay, good morning, everyone. I'm Meha Jha. I kind of wanted to, this presentation, kind of get a feel of like what industry people are in and the type of reporting. So this angle is going to kind of actually come from the measurement side, the field of maybe helping you guys understand where some of the inaccuracies come in with what you kind of maybe see on your end. So I just wanted to get a feel of just your industry. I mainly focus in on refining and green diesel, but just wanted to, I'll try to broaden it based on the audience. And so I guess how many is anyone in refining or focus on refining? So we have a couple, any for green diesel facilities with your refineries or adding green diesel or renewable diesel production? No, okay. How about like oil and gas, midstream, chemical? Okay. So a good bit there. Okay, so what we'll do is try to broaden, and then do y'all do a lot of the sort of, are y'all all the emissions reporting, the greenhouse gas emissions reporting, EPA, all of that is kind of y'all's scope of work, just to get a feel. Okay. Everything. Okay. Okay, you have wastewater. Okay. Okay, great. Okay, so this is kind of part of Emerson's track around sustainability. So curious for you guys as like ESG or HSE of how has your scope of role changed any with sustainability targets or the focus or resource or allocation with companies changing targets or anything like that? Like, is there more data? Okay. That you probably don't have, right? Are they even, I guess, are they even investing or implementing in terms of software or like tools to help y'all get the data? But I guess, do y'all have the belief of garbage in is garbage out, kind of, you don't trust the data or, yeah. Okay, so we'll talk a little bit. I'll kind of retailer, just kind of talk about this, trying to broaden it to all of you guys. So just in the range of, sustainability, this is kind of part of our sustainability track all day of kind of, this is maybe the three umbrellas. I get asked this a lot of how kind of Emerson is viewing it, with you guys really being around the emissions monitoring sort of piece. Do any of y'all do carbon intensity scores or carbon calculations as part of your scope of role? I wouldn't think if, okay, just wondering. And then do y'all have maybe where y'all are investigating around, like whether it's carbon capture or some of these ways for carbon improvements? Okay, so whether you have it now or you maybe see it forthcoming, we'll talk a little bit about that and what the reporting requirements kind of are looking like and what we're seeing, maybe some of the challenges. So hopefully, if anything, it'll be a little bit like educational or futuristic of maybe what could be coming your way. So let me move forward. So kind of this is in particular, I guess, a refining example, but I think a lot of similar applicability maybe to, we can generalize it for your industries. But as far as measuring and monitoring sustainability, in particular, I know refining, we have the Solomon Index, which people have maybe already been tied to what's called the energy intensity index around a refinery's energy consumption, where they will report that. So they typically do that benchmarking every couple of years based on complexity of the refinery, based on the type of crude they're processing. Like there's a standard benchmarking around there. So reporting in that space has always been pretty consistent. I think some of you guys, is anyone petrochemical here has petrochemical? So like the refinery sector rule got applied to the ethylene side of the business for compliance, very similar requirements in terms of the accuracy on the flow rates, how often you have to report, the calibration requirements. So you maybe are familiar with that in your space. Carbon capture or carbon intensity score. So this one seems maybe new to some people or maybe forthcoming. So one of the things in the US as of right now, there are state and federal credits for like fuel credits or regulatory blenders tax around transportation fuels. So really diesel right now. So there's something called renewable or green diesel. I don't know if y'all have heard of that term or kind of are hearing how people are taking feedstock like corn, soybean oil, and they're making it into petroleum diesel. And it is compatible with like engines. So there's no blend, like typically ethanol has to be blended, traditional biodiesel has to be blended in with petroleum diesel to meet compatibility. This green diesel is purely what they call a drop-in fuel. And this is kind of where I would say we've seen the first wave in terms of the government incentivizing this sort of like renewable production, as in like there's credits. So as part of those credits, the government has the low carbon fuel credits, which actually that should say LCFS, but there's something called a carbon intensity score that I've mainly seen like ethanol or some of those more traditional renewable companies have done, but it's something that's starting to hit a lot of major oil and gas people in terms of focusing on carbon intensity. So I think how familiar are people with it or not? We'll talk about it a little bit more of what exactly that is. My whole point in bringing it up is, so even on the chemical side of the business, we're seeing people use like renewable bio-based feedstocks as well now, compared to traditional like petroleum or coming in from a refinery. And then at the same time for refining, or even whether it's renewable natural gas, there's kind of this whole sort of talk, right, of alternative fuels, hydrogen, different things like that. These all have some sort of carbon intensity. So we'll talk about that and what that sort of means. So carbon intensity is essentially how much CO2 is emitted from the complete life cycle of, in this case, it's of a fuel. So for example, that is literally from, like when we talk about green diesel, that is literally from seed, like the agriculture, the crop itself, all the way to tailpipe emissions. And typically for green diesel, it's about an 89 to 90% emissions reduction across that value chain. It's more expensive to produce renewable or green diesel. And that's why we're seeing government incentives to help try and make it lucrative or profitable for like refineries or other operating companies to produce it to scale compared to petroleum-based diesel. So that's where this carbon intensity, the reason it's so important is because it ties to how many credits, fuel credits they get. So it kind of varies based on the type of feedstock that they select. It based on how well you operate in terms of how efficient you operate and how many emissions come with the actual manufacturing or the conversion of that bio feedstock to a fuel. But then there's also opportunity, which your companies might be investing with some of these fuel pathways where you can improve it in addition to just feedstock and processing, but also on like a carbon capture side or some sort of emissions reduction focused, or putting renewable power on the grid with how you manufacture. So it kind of hits your guys' awareness in that way of kind of what at a corporate level they think. So these companies have to hire these specialized accounting firms when they're doing these sort of business evaluations on these projects, that what they're doing is estimating all the way from, you know, whether it's the carbon capture phase to like, you know, I guess the production all the way to sequestering carbon capture, or whether it's to end use. And so this is kind of something I guess I would say in the refining space for sure has been kind of new and just a different sort of focus with optimizing these fuel credits. One of the things to note, as I said, is right now it's only for green or renewable diesel. Have any of you heard of the term SAF, sustainable aviation fuel, or renewable jet fuel? So currently in the US, it is not incentivized for producers to create that. So there's not like these tax credits that a company can file for producing this. However, on the airline side of the industry, like we're seeing where certain airlines are announcing that they're going to use a certain percentage of sustainable aviation fuel going forward. So from a consumption standpoint, airlines have already started to adopt it. I think even I've heard like JFK is going into a lot of, there's like a terminal kind of modification project we're working on where they're trying to use sustainable jet fuel for the fleets there. But on the producer side, it's more expensive to actually produce jet fuel, and it's not incentivized at the same time. So I do foresee that it's probably going to be something that's going to get incentivized, and we're going to start to see whether it's new capital builds come online or things like that in this space. So just something to kind of be aware of. I think we're also hoping or anticipating that some stuff like carbon capture, like the government would, you know, incentivize as well around this, right? So let me move to the next. Okay, so whether it's a low carbon fuel standard or whether it's any sort of reporting you guys do, I think you guys can heavily relate to the fact that data accuracy and measurements matter. So for you guys, I guess, do y'all ever work with your yield accounting teams that would pull together your master energy balance for like your kind of nature of work, right? So in the case of some of this credit reporting, what the government in the past, like usually yield accounting, energy balance, that was nothing that ever had to be reported to like a regulatory agency, right? It's kind of your more internal to corporate to finance, your own sort of accounting. In the case of whether it's like renewable diesel production or some sort of like the bio-based like production, you are actually required to report all your utility and your consumption, your hydrogen use. And so that's kind of different in terms of, in the past, it was maybe kept for internal purposes, right, or your plant. But for some of this credit reporting with the government, it has required sort of your mass balance, your yields, everything like that. What's tricky is if you're at a facility where you're co-sharing. So for example, you have a renewable unit or a carbon capture attached to like a refinery or things like that, or you have multiple facilities feeding into carbon capture, you have to know that allocation, right? That's what's tricky of how much is going to just general refining in this case and how much is actually going to some sort of renewable unit. So there's a lot that goes with the reporting. From a measurement standpoint, which is where I play into with Emerson, is the instrumentation and maybe understanding the gaps that you guys see with your accuracy or your data. I'll kind of go into that. But typically the top three things that I put in here when it comes to the mass balance or the energy balance in terms of error is usually that there's some sort of manual data entry error usually. Especially on the yield and the mass balance accounting side. So if you guys ever work closely with your finance teams, a lot of times where if you have truck loading or unloading at your facilities, loading and unloading operations, a lot of times depending when they record that and depending on end date, there's a lot of kind of having to go back and forth with entering those in for your calculations, right? That can kind of mess them up. There's measurement errors, which we'll talk about today. Measurement sources of error is typically what I see a lot of the kind of gap between where you guys sit at a corporate sort of level to the field level, right? There's usually some sort of between operation and reporting. A lot of times it stems to the measurement error, which we'll focus on. And then there's, of course, always missing data. So the three things about measurement sources of error and how they can kind of be what you see when you get the data is it's centered around instrumentation accuracy. The second is maintenance and calibration. And then the third is changes in process conditions and compositions of materials being measured. So I don't know if any of you are at facilities. So for example, in the refining space, this would be like processing different types of crudes. Crude oils can impact the accuracy of what you see. I don't know if y'all have any sort of feedstock changes or product yield changes that you do at your plant, but a lot of times, depending on the instrumentation is most often typically calibrated for a certain process fluid and certain process conditions. So if there's any variation in your facilities, it typically impacts the accuracy and what you guys see on the reporting end. So a lot of times, depending on what they selected, that's where the gap is. So we've done a lot of work in terms of energy and mass balance. And I would say a lot of times the target is about, for a facility is to be in about 1% accuracy on your closure, for a process unit about 2% accuracy. And I would say more often than not, we have seen those targets not met. So those are typically the ranges that I see both on the refining and chemical side for accuracy around the mass balance. So we're going to talk about some sort of we'll be instrumentation people for a slide or two of trying to explain the why of maybe you see some of these inaccuracies in your reporting. So how many of you have ever heard of these type of meters? An Orifice plate? Yeah, that seems to be the most common in most industries. How about a Coriolis meter? Okay, so starting with kind of the Orifice meter, this is pretty much the most common baseline, well-known, well-established flow measurement meter utilized across every industry. Super versatile, super cost effective. How many of you maybe have had sources of error and accuracy because of an orifice meter or a traditional volumetric. I see some heads nodding. Okay, so if you look at this sort of flow equation that I have by this orifice meter, that is all of the that is the equation to calculate mass flow and from volumetric flow. And you see all the different variables, and then you can see how much the variables are impacted by whether that's a change in differential pressure, pressure itself, or temperature, right? So you see all these sort of components that feed into this equation. And so what is very tricky about orifice meters is they're very reliable for control, but in terms of high accuracy applications, so for example, if you have to report fuel gas flow consumption, right? Natural gas consumption. If you have permitting issues off of a certain process unit, a lot of times, especially in like a refinery, it is an orifice plate meter. And so depending on if feedstock changes or if you're running different pressures or temperatures across that unit, you can have inaccuracies that come through your reporting. And so the orifice meters, they are impacted in terms of they have to have compensation for changes in temperature and pressure. What a lot of people end up doing is, right, to get from mass to volume, you have density, right? You need density. So they take lab samples of density, but what they don't realize is that if your actual fluid properties are changing, then that density is not representative of the fluid. So sometimes people will take an average density or they'll run a lab sample, not very frequently, but they'll use that. But more often than not, your actual process fluid or property is changing. So that's where an inaccuracy you may see in your flow rates or there. The other challenge with orifice meters, so the misreading can be with the process fluid changing itself or the process conditions, but the other can be, and is very common, is incorrect installation, maintenance or calibration records. So many times most people can't find them when we work with them, like they can't find the manual records of when the last calibration or maintenance check was on meters. If you're in a colder climate like your facility is, these tend to be prone to freezing or plugging. I don't know if y'all have experienced that at some of your facilities, and there'll be a false reading, the meter will go down. If it's plugged, that will also result in an inaccuracy. So there's sort of kind of, these are just kind of some of the whys behind maybe where you see some inaccuracy in your reporting. On the other side, the Coriolis meter side, so Coriolis is a direct measurement of mass, right, which is required even though you may operate in volume, like a refinery operates on a volume basis for control. Chemical utilizes more mass-based control than refining. But even so, on the mass flow side, you have density, calculated volume, and the Coriolis flow meters are not impacted by changes in properties or process conditions. In addition to that, there are diagnostics that the Coriolis meter has for reporting and maintenance. And so, for example, on the green diesel side, like with the reporting there, we're seeing more people implement using Coriolis meters within the process because of all those reporting requirements and the accuracy required. And so on this next slide, I'll talk about a little bit. So in the past, what your field team would have to do for reporting and meeting the calibration requirements, and this is the same for whether you did the refinery sector rule, whether you're doing the ethylene rule, where you're typically or any EPA reporting, whatever the calibration is set, whether it's annual, biannual, a lot of times you can go with like a manufacturer's recommendation, right, to kind of bypass having to pull the instrumentation offline every year or two. But traditionally, if you have an orifice meter, these are the steps that are required. You have to zero span the transmitter. You usually have to maybe pull the plate offline and inspect the condition. You have to measure like the plate, and see just kind of if there's any wear or tear there, because all of that impacts your accuracy. And so these are all the steps, versus now there are online diagnostics for some of the more advanced meters. So for a Coriolis meter, for example, there's something we call it smart meter verification, which allows you to verify the meter online. Have any of you ever used this in your facilities or familiar with this? Okay, so So this is actually also available for mag meters. So I know someone had water as well. So I don't know, have you ever used it on a mag meter or to verify the accuracy online without having to pull the meters offline? Or do you know? Okay, that's okay. Yeah, no, it's okay. Well, sometimes people aren't aware that for you guys from a reporting standpoint, traditionally, either you had like a spare meter that if you pulled one off, you'd put one on to keep production going. You'd send the other to the lab, right? So you carried on spares. So instead of doing some of this traditional, or you pull plates off, put ones on, having to send to a lab to validate, the EPA, they have this clause for most reporting. I don't know if I have the slide in here where they allow you to take the manufacturer's recommendation, right? Like you're familiar with that language of you can submit whether it's 10 years of calibration data that shows stability, right? There are certain things we can submit to kind of bypass some of those requirements. This is one of those. So this, people use it whether it's for maintenance purposes or they use it to bypass calibrations or some of this reporting. So what this does, it's on mag meters and it's on Coriolis meters, is it basically is at a push of a button, like the operator can do it in the field or you can do it from the control room. You can configure it how often you want in terms of frequency. But what it does is it basically compares the meter to factory standards. So it compares it to what the accuracy, it kind of runs a check on testing the integrity of the meter, and running diagnostics around there and the electrical components to basically verify. So I won't say validate. Validation is, the term for validation would be like when you take the meters offline to send it to a lab. But these sort of diagnostics can actually verify that you're within baseline factory standards on performance. A lot of times it can detect abnormal conditions. So if you're seeing two-phase flow, if you're seeing corrosion, there's ways to detect. So that's one piece. The other of why people are using it is that it leaves a digital sort of trail. So this is like a sample of one of the reports. What it does in terms of from the reporting standpoint is you can have a historical log. You can set a frequency of how often you're verifying the meter, because the EPA, if you are out of compliance on an instrumentation, they can fine you up until the last time you can prove when you were in compliance, right? When you were, the meter was performing or whatever. So this is like kind of an audit trail that it establishes, and it's used not only in terms of like the EPA greenhouse gas reporting, fuel gas consumption reporting, we've seen it used for custody transfer as well in the contracts there too. Okay, so the other thing, and this is for your guys' awareness, just in terms of education around if carbon intensity or this sort of hits your plant in the future, there's a piece of a component of what it's impacted by, but it is around the feedstock, like the bio-based feedstock, but then the big portion is energy and process conversion. But regardless, I would say whether you're doing any sort of carbon reporting or not, you guys, in terms of falling under ESG, in order to reduce emissions, energy emissions goes hand in hand, right? So the projects go hand in hand around that. So these are kind of the areas in terms of improving energy efficiency in these sort of spaces. And at the same time, if you improve your energy efficiency and reduce emissions, it helps you improve your carbon intensity score. And if there are credits tied to that, then it helps in that, there's a financial incentive to it as well. How many of y'all, do y'all have facilities that are participating in the Energy Star program for EPA? Okay, so have y'all just recently signed up for the challenge or been part of it for a while where you're doing, because they just relaunched a challenge, I think last year, where are some of you not familiar with it, the E-Star program that I'm talking about? Okay, so the EPA E-Star program, you might have actually seen it on personal electronics like TVs or like alarm clocks or things, but they also have it on the industrial side. It's over about 30 different industries. And what it is, they have launched this E-Star challenge where there's no financial incentive. It's kind of more like a stamp that your company can put. And the program itself it's committed across 5 years to a 10% reduction in energy consumption at a facility. And they have these tools that you can benchmark where you are at. And depending on the industry you're in, the EPA had consultants that actually put out public reports, if you go on their website, and resources of recommendations for improving energy efficiency. They also have it around greenhouse gas reduction. So they have two reports. They have an energy side and an emissions side. A lot of the reports overlap because typically most of the time with combustion processes or other things, energy and emissions are very tied together. But for your guys, some of these projects help in that regard, with like energy and emissions tied together. So I kind of wanted to maybe touch on some of the different ways we're seeing HSE and environmental improving, whether that's energy efficiency or emissions reduction. So how many of you guys are familiar with, okay, how do you monitor steam traps today in your facilities? Or do you know, or do you have issues with leaking steam traps? And how often are they inspected? Any comments there? I'd say typical fail rates I see are about 5 to 10% of steam traps failing in a plant a year, but maybe once a year they're manually inspected. Does that, people may know, not? Yes. Yes. Yeah. Yeah. Is it typically, do you know how many typically, like 5 to 10% or about? Yeah. Oh, wow. Okay. So it's gotten better. Okay. So question, I guess, around, do you know how much some of those leaking steam traps impact your boiler, like duty that you have to put on a boiler if you have a boiler? And okay. So I guess the reason I kind of illustrate that is because steam traps, right, or steam may not seem as big of an issue in terms of, okay, we have some leaking steam. There may be some quality impacts on the process, on separation for a distillation column, but depending on how much steam is leaking out of those traps, you're then having to put more duty on your boiler, right, to generate the steam that's being lost. And so one of the ways we're seeing people from an HSE standpoint improve this is that, so what he brought up was the traditional way of typically people maybe bring someone out every 1 or 2 years. They manually inspect all the steam traps. And then I said the average percentage we said was about 5 to 10% is what we see in terms of failure rates. So leaking traps usually are traps that are stuck or have like condensate in them, like water that has built up in them. So the newer sort of way that we're seeing people do is they prioritize what are critical steam traps, whether that's tied to a safety system, whether that's in terms of volume or quantity of the steam. And what we're seeing is there's kind of a new way, acoustic monitoring. How many of you have maybe implemented that anywhere in a plant or are familiar with that? So what we're seeing is people put acoustic monitoring on steam traps, so on their critical ones. And what this does is it allows them to detect not only, well, number one, identify like where the steam trap is, because thousands of steam traps, hundreds and thousands, right, are in a plant, right, when you think of your steam systems. So it helps pinpoint, it helps early detection, and in terms of like maintenance, so you can detect right away, right, and identify those leaks or those issues. So this is kind of what I consider like a very much like a low hanging fruit, where instead of having to bring someone out once or twice a year or use your operating team to go and have a schedule where they're inspecting, this has allowed people to kind of more quickly, as well as reduce energy losses. And we actually, at least for the refining space, we actually have a calculator based on kind of the refinery configuration as well as industrial data and costs that we can actually estimate like what the savings would be around there. So we've done like a lot of these justifications for steam traps. So that's kind of one of the maybe newer ways we're seeing people kind of improve reporting or try to reduce boiler duty emissions in that way. This other one is kind of interesting. So how many of y'all have fired heaters in your facility? Yes, no, a few over here. Okay, so in a refinery, the EPA, they had data that came out around like how much a fired heater contributes, or like combustion is about over 60% of, like 63% of the emissions for a refinery. Do you know how much for your facilities you'd say your fired heater contributes to emissions or energy? Typically, I'd say they're probably your biggest per single asset, right, consumer or emitter, right, in terms of that. So for a refinery, they have about 20, they average about 20 to 40 fired heaters. So the contribution to greenhouse gas emissions is significant, but an ethylene fired heater is massive as well, just the singular one. So it's usually your biggest contributor in terms of that. So some of the ways that we have seen people improve, right? If you can improve the combustion control, right, operate with less excess air and less fuel consumption, right, that really hits in terms of your emissions. So this one is actually interesting. So there's a fired heater committee called the API, or if y'all are familiar with API, American Petroleum Institute, right? They have all these design and operating practices. So for fired heaters, they look at the safe operation of fired heaters. And they did this study, which I'll talk about what this data kind of looks like and means, but what they were doing was they were investigating it primarily from a safety standpoint of how do they prevent heaters from tripping, like what's the best control methodology from that regard. But at the same time, they wanted to look at the economics and kind of the environmental impact. So for fired heaters, my guess is typically for some of you that have them, do you know if you're running fuel gas or natural gas? Fuel gas, both. Okay, so especially if you're doing like fuel gas, right? I think y'all can attest to how much the composition can vary from that, the quality of it, especially if you're taking off gases from your facility and dumping it into your fuel gas system. Depending on that, there can be a lot of variability. Or natural gas tends to be more stable in terms of quality, right? But fuel gas, if you're using those for your heaters, the fuel gas quality impacts the amount of air you need, right? So that's where the variability and control comes. So if you look at the bottom two charts, what you see is fuel gas composition on a mass basis and on a volume basis. So if you look at the bottom, you'll see the variability by mass and volume. So you'll see these are two example fuel gas cases where you see like on a mass basis, I think it's about a 3% or like on the first case, a 3% versus like a 15% in terms of variability around the composition. And so why this kind of matters and what this is trying to illustrate is most people operate their fuel gas control on a pressure or a volume-based control scheme. So the fuel gas flow is either controlled pressure or volumetric. But anytime if you're using fuel gas and you have this sort of variability, you're seeing it can impact your control scheme. So typically what ends up happening is a lot of times if it's what we call a rich fuel gas where it has a lot of high BTU content, the air requirements are not like set up in the control scheme in terms of there's not enough sufficient air for the complete combustion. So you get your oxygen in the stack ends up depleting faster, hitting that low threshold, and the safety system cuts in and it trips the heater. So we often see the heater tripped because of we call it a rich fuel scenario. And so given that, most of the time we're seeing that kind of be like a common incident in the field. So what the API committee did was they ran different control schemes of controlling the fuel to air ratio on a mass basis, on a pressure basis, on a volume basis corrected for pressure and temperature. So they ran about 6 scenarios. And what you see here are 3 charts. They have about 6 charts, but I only put the 3. And what you can see is what this chart did was the simulation took historical fuel gas composition data from a refinery for about a year, and it grouped it. So the tool, and we have this tool at Emerson, what it does is it grouped it by category. So it'd say fuel gas 1, fuel gas 2, fuel gas 3, based on composition, how consistent. And it ran a Monte Carlo simulation where it would go from fuel gas 1 to fuel gas 5 to 7, right? It would simulate what it would be like in a plant with your fuel gas variability. And what it did was it plot these histograms, these frequency charts that show the number of times that you're deviating from your set oxygen on a fired heater. So what you see is how much you're varying on your control scheme of what's required. So it also shows you the range that you should be operating in. So if you look at it, you see the pressure, the volume, how wide and variable, but on the mass basis, you see it's much more narrow. And so what we're seeing is people implement Coriolis not only on fired heaters, but actually on boilers as well. It's the same exact principle for combustion control on fuel gas to air. And this allows you to lower that target oxygen, right? So you see the band is a lot lower. And then typically when I work with HSE, they are able to, the tool cannot do this, but HSE can then go and calculate the emissions reduction knowing that the lower oxygen. But the benefits are around safety, energy efficiency, less fuel consumption, reducing the probability of tripping a heater as well. So it has a triple threat benefit, but this is one of the more common ways I'm seeing in the refining and chemical space in terms of trying to reduce emissions in the field. This is kind of one of the more popular implementations. That API practice that I referenced, I think the new standard, it was supposed to come out in 2022, but I think with COVID, there's some delays, but they have actually rewritten and redrawn the control diagram in the practice to put a Coriolis meter instead of an Orifice plate. So this is kind of something that the community of practice has started to adopt, but also a lot of HSE. And we at Emerson, so I ran these cases, like we actually have this tool that the committee asked us to develop, so we can actually put these simulations. So I'll take historical gas from a chemical plant or refinery, and we can actually run and show you if there is like a net present value, like return from an economic standpoint, and what that target O2, like how much it can lower. So in some cases, depending on heater duty, you know, it may not be economical, but in other cases, so we can run that business case as well. The other area, very similar to steam traps, like what we talked about, but sort of the same concept. For pressure relief valves, are any of you guys monitoring? Are you doing the same sort of thing where your operators kind of go into the field and look for like leaking valves, or you try to use the control system? Do any of y'all have online implementation of monitoring your PRVs, or the ones releasing to atmosphere or anything like that? Anybody? No, don't know. Okay. Very similar in terms of, we actually have demo units if you want to see the steam trap monitoring and the pressure relief valve monitoring at our booth, where we can actually show you how we can open the valve, show you we can show you the leakage. We can show you the simulation on the software for you guys to detect if you want to stop by. Marcio's in the back of the room here. He's my colleague who, this is his heart, is what I would say, of what he loves to do, and does this a lot all over with refining and chemical, but very same concept of that we talked about with the steam traps in terms of, right, the traditional way was manual, trying to maybe look at the control system, trying to look at data, detect when an event happened, try to figure out how much leakage occurred right out of these valves. What this does and what we've seen is the same as sort of concept of people prioritizing what are the critical PRVs, and this helps in terms of identification, right? Immediate identification of something leaking, as well as on the reporting side with knowing the exact amount, it's timestamp data. So we've seen this sort of implementation in front of the HSE side of better improving the accuracy there, or preventing, right, further leakage or quicker detection around here. So especially when the refinery sector rule came out, we've been at this conference the last 4 or 5 years. This was something that a lot of HSE personnel came to talk to us about around their flare systems and the PRVs there. And so this is another kind of newer, different way people are implementing there and trying to improve reporting. So this one is carbon capture. I know someone in the audience kind of mentioned maybe that this is going to be something that a plant is looking at in the future, or maybe your facilities will go into a like centralized, like a shared carbon capture facility. So with carbon capture, I've seen like some companies like throw out different kind of business models of maybe they want to put it at their particular site, but they're looking at how can I monetize and get maybe wells around my facility that are not part of my company to also share into this, right? Or if you are in the Gulf Coast, you're familiar maybe with some of the partnerships between Exxon and other people that are kind of being announced about trying to put together carbon capture there. So nothing has like materialized in this sense, but one of the big things about carbon capture is the measurement itself is very challenging, like CO2 to measure the CO2 that is being captured. It's a very difficult measurement because of the critical phase that it's in, the variable density and the high velocity of sound. So this is kind of another area in terms of accuracy and what people are having to maybe invest in better accuracy around is with like using Coriolis meters. So it's just something that trying to make aware of, you know, with some of this new sustainability stuff, there are newer challenges that are maybe coming in on a measurement side that weren't previously there, right? Whether it's feedstock variability, whether it's the accuracy in reporting now, if it's to the EPA or if it's for carbon intensity purposes, like the score, whether it's for credit optimization. But all of these are kind of newer measurement challenges that may not have hit your desk before that you might kind of be required in terms of reporting. But at the same time, there are some of these like the acoustic monitoring sort of, or the using Coriolis for combustion control, newer ways that people are improving reporting, being able, whether that's from an early detection and accuracy standpoint. So that is all I had for this presentation. Are there any questions? I did want to highlight, I kind of mentioned it, for the steam trap monitoring and the PRV monitoring, we actually have those demo capabilities set up. This is our booth number where you can find us. We're close to the food, so if you decide to have lunch and I see you, I will pull you over. But so we can actually see that and how the software tracks the data, what all metrics you can get. Marcio can actually run business cases with ROIs and stuff as well, and he'll be, I'm sure, at the booth, and we can help you there. But any questions? I appreciate y'all's support and comments. Thank you so much. And I'm up here if you want to ask something like privately or anything like that, or I'll be at the booth as well. Thank you guys.